Hello ROS developers, it's Rodrigo from The Construct. Welcome to another video. Today we're going to be learning how to use an action server in ROS2. And for this we're going to be using our platform The Construct and using a simulation of the Turtlebot 3 in order to show you what you can do with action servers. So let's go, you guys. Okay, so what we're going to do here is go to our platform, which is called theconstructsim.com. Let me just go back to here really quick. And if you don't have an account, you can quickly create one. And once you're in here, I'm going to be sharing a ROSject in the description below. So make sure you check the description for a ROSject link. And it should appear, what should appear should be this, which is a ROSject where we're going to work in. So make sure you click on that and something like this will open up in your screen so you can go ahead and run it. And while it's loading, let me just go back to theconstructsim.com and show you guys what you can learn with us. You can learn ROS and ROS2 for beginners, so you don't have to know anything. You can even start learning the program with us, and you can take robotics theory courses and practical courses. We have over 50 courses, so I recommend you guys come check it out so you can get started with your ROS learning. Okay, so we're going to go over to our ROSject here, which is where I have put the base simulation that we're going to be working with, just so you can see the utility of an action server. So while it's loading, let me just explain really quickly. An action server is sort of very similar to a service server in which you have a server side and a client side. So you can run an action server and then call an action or call a service. The difference between a service and an action is that for the actions, you can send a goal, a task, and the robot can be performing it while it's doing something else. It doesn't block the entire program, as opposed to a service where you have, when you call a service, you have to wait for it to return the answer for your service. And in the other side, on the action server, you can call the action server and it will do the task that the action server has inside, and you can do other things in the meantime. And you can also get a feedback message to know how your action is doing. So that's basically a quick rundown on how what action servers are. So it seems like our ROSject here has opened. So as you can see here, we have a ROS2 Turtlebot sandbox. This is just some packages that Robotics made for us, and so I just have compiled them in here so you can get to working with your programs really quickly. So here, as you can see, there's an instruction on how to run the simulation. So we're going to copy this, and over here are the terminals. So we're going to go ahead and copy that in order to see our simulation. And nice thing you can do with the terminals is rename them. So I would call it sim for simulation. And to see the simulation, we're going to click on this button right here, which is the gazebo. This is the simulator for ROS and ROS2, the default one. So we'll just wait for it to appear really quick, and just to show you what we should do. Again, while it's loading, let me go back to what we're going to do. We're going to create an action server with a custom action message. So there's two things that we have to take care of. First, we're going to create our custom interface, which will be an action for our Turtlebot, which will be a command for it to patrol an area of a certain radius. So we're going to create a message for the action, a custom one, and then we're going to create the server so we can call it and see the Turtlebot patrol this area right here that we have it's shown up here. So as you can see, this is our simulation of our Turtlebot. That's just a little world that Robotics made, and here over here you can see the Turtlebot with the laser rays. This, you can just visualize them right here. So we'll just see them for the top just because it's easier. And all right, so let's get moving. Let's get started. So the first thing we need to do is we're going to be working under this workspace right here, ROS2 workspace. We have the Turtlebot 3 workspace, which is where the packages for the Turtlebot 3 simulations are. We don't have to touch this. So we'll just stick with the ROS2 workspace right here. All right. So the first thing we're going to do is create our package for our custom action. So we are going to go over to the ROS2 workspace inside our SRC folder, and we're going to create a package. For this, type ROS2 create package, build type. Oh, another thing I forgot to mention is that we need to create, for our custom interfaces, we need to create a package that has a CMake amend build type. So if we do build type like this, amend CMake, and we're going to call it custom interfaces, and we're going to set some dependencies. Let's see if this works. Okay. I needed to do package create first. So this is the command, actually. I mixed the words. So in here, we again set the type to amend. I'll make this a little bigger for you guys. Amend CMake. We're going to call it custom interfaces. And we're going to set some dependencies. So dash dependencies, that's how you set them. We're going to create, these are some of the things you will need. Obviously, amend CMake will be there already. So action messages, because we're going to use an action, and standard messages as well. And the last thing we actually do need for this is ROS-IDL. I'll just make this bigger so you can see it. Default generators. This will create, this adds an instruction for our compilation to find these custom interfaces. So for that, you just click enter. And it looks like now we have that custom interfaces package right here. So good. Next thing we're going to do is right away, we're going to create a folder named action. And in there, we're going to create a file called control.action. This will be our custom action. Okay, so now we have a file here. We can go over to the IDE. This is the button right here, and check that in fact we have a file called patrol.action. And this is one of the things that is specific to actions. First, we're going to define a goal. And for this, we can do a float 32. And let's say we're going to set it as, just separate them right here. Goal, result, feedback right here. That's how you separate them. You just put some 3 dashes like so. And in here, we're going to put the feedback. So for the goal, we're going to set, let's say, a radius. So we're going to tell it to move along a radius of a certain, of a circle of a certain radius. And then we'll do just a Boolean for the success. And as feedback, we can do, again, a flow 32, we can do a, let's say, time left. So the feedback you'll get is the time remaining in that patrolling behavior that we're going to send to our robot. So that's our custom message for our action. Okay, you can also use default standard actions, but this is just an extra so you can see that you can also create your own actions. All right, so next we're going to check our CMake list and package XML. Let's make sure we have everything we need. One thing first, for the CMake lists, we're going to copy this. I'll just tell you what it is. This is the 2 things we need, and you can paste it just wherever in your CMake lists. This is just setting a variable called action files that's pointing to our folder action patrol.action. And remember the ROS IDL generator. So this is where we're going to create our interfaces for our project, and we're going to use this action files, which is that patrol.action. And we're also going to add dependencies like we did while creating the message for action messages and standard messages. Okay, that's all you really need. And for the packages, there's a couple of things we need to add. And if I go back here, we need to add the dependencies that are needed in order for this action to work. So we're going to copy this, paste it over here. So as you can see, since I already set the dependencies to be action messages and standard messages, we don't actually need, and the ROS IDL default generators, we don't actually need this or this or this. We'll just need the built-in interfaces, the ROS IDL default runtime, and we also have to add as a member of group the ROS IDL interface packages. This is every time you need to create a custom action, just make sure you add these in your package XML. All right, so let's see if our package compiles and if we can see our action. So if we go back to the ROS2 workspace and just compile with Qualcomm build, we should just wait for it to build and see if we can see our action. Right now it looks like a good sign because it's compiling everything for the action message, so it should take a little longer. Okay, looks like it finished. Next, we're just going to source. You can type in source or a dot for that, and it's install setup bash to source our workspace. And we can actually check by typing ROS2 interface show, and if you press tab, we can start typing this. So this will be the type of the action of the interface. It could be a send service or a message that you want to see. And this is done with the package name. Remember, we called it custom interfaces up here. Then it goes to the action folder and the patrol. And then let's do like so. And there it is. So it seems like ROS2, our system is finding the message that we have. So we can go ahead and start working with the action server that will use this message. All right. So for this one, we will create another package just to keep things nice and separate. And this we can make it an amend Python, so we can work with a Python file. So just a little easier because I just want to show you how it works. So for this, we can just call it, let's say, patrol action server. And for dependencies, let's set them. You don't have to add the dependencies, but once you start building the program, you'll probably run into problems if you don't use RCL-LPy for dependencies. And for example, we're going to be working with a twist, which is a message that's in the geometry messages. And we're going to use our custom interfaces package. All right. So it's been created again. So we're going to go over to our new package, Patrol Action Server. And under here, under the next Patrol Action Server, we're going to create a file. You can also create a file this way, so it's nice with touch, or here you can just say patrol action server.py. Okay, so in here, I'm going to copy this code I have prepared here, which is our action server. All right, this is a combination, an adaptation of one of the examples from Robotics, so shout out to them. Just modified it to be all in a single program in order to be able, for it to be easier to explain how this action server works. So let's just first, before I explain it, let's make sure it compiles and everything. So in a Python package, we need to check that we have the dependencies that we have made, that we specify while creating the package. They're here. And we just need to create an entry point for our node, our action server node. So that's done in the setup.py. And when you see the entry points under console scripts, this, I recommend you guys do it without looking, because a lot of the times you can just copy paste, but you don't really understand why. So this is how it's done. Like, you want the main function to be executed in what? In the file patrol action server with 2 dots here. And then with a dot, you need to say which package. Well, it's the same name, patrol action server. And this whole thing will be the executable. So the executable, I always like to call it patrol, the same name with exe at the end, like this. So you know it's the executable, and so that way you keep things organized. Okay, so let's see if this compiles. All right, so it compiles. So technically right now, I could launch it. I could launch my service server. Let's just check that, and then I'll go on to explain the service server. I'm sorry, the action server. So for that, we would just do a run, name of the package, and name of the executable. You see, here's the exe that I added. Okay, it looks like it's working. So that's good. It's running in the background, so let's go ahead and explain it. All right, so we're going to go over to the file. And it's pretty simple. These are some of the things you'll need to add. Like I said, RCL-LPy. And for actions, you can add these three that are specific for actions: a cancel response, a goal response. Remember, we have a goal, a feedback, and you can cancel actions. So this is just to add a callback that will cancel the action that's been done. Then we're doing reentrant callback group and multi-threaded executor in order for the system not to be blocked if we are doing a lot of callbacks. So this, you don't need it specifically, but for that's another video for multi-threaded executors. Make sure you check it out. So, all right, and then of course we added our patrol action cut from our custom interfaces, that action. So we create a class. So the way I did this, way you should do it too probably, is I went to a ROS2 templates, which is really good resource because I never remember exactly how to make all of the nodes, right? So in here you'll see a bunch of, it's for ROS2, a bunch of examples. For example, an action server. So I recommend you guys, if you want to start with this, I think they'll do the Fibonacci stuff, which is a terrible example, but anyways, the structure is pretty much the same everywhere. So I recommend you guys take a look at, I'll put it in the description too, the examples for ROS2, which is a great way to just start a node. So you'll see a bunch of functions that I have here that I just copied and pasted, and are just really useful. For example, our cancel callback. This is if we want to cancel our action, and a goal callback as well. And then the execute callback, which is where we put our main code for what we want the action server to do. So as you can see here, we're just creating a publisher for command bell because we're going to be modifying that topic to make the robot move. Then we set a goal for our patrol goal. Remember, it's coming in from our definition of our custom messages. And then over here we create the action server, right? Since it's a class, it's itself here, and then patrol, our message, the name of the action that we want to call it. And then normally you only put, if you're doing like a minimal version, you only need this one to work, which is the execute callback. But if you want to have a one for the goal callback and the cancel callback, so you can do that, you can add these here. And this callback group is to be able to do multi-threaded executors. So that's how you create an action server, like so. All right. So then this is the message we saw, and just a couple of these default callbacks that you don't really need them, but to have them in here is really nice in case you do need them. You can do something else when you cancel an action or something. But our main code is the execute callback. We're going to be then using a radius and a set speed of 0.5 so the user will input this radius, and then it's going to use this radius to figure out how much it has to drive in a circle. And then with this, it gets a total driving time that you can then subtract it for what the time left is, which will be our feedback. So our feedback message of time left, while it's less than 0, it's going to be performing the action. So what it's going to do basically is just move in a circle. That's it. So it's going to be checking that message time left that we have from the total driving time, because we know how big the circle is and how much it's been running on with the duration function. And then we're just going to publish that velocity right here to our robot, and then just set a rate. So it's just going to go in a loop while this condition is true. All right. So far so good. And then at the end, when the action is completed, right here we're creating a empty twist message, so the robot stops. So this will make the robot stop. Then the goal handle will be a success. So we send this, and we send the result, which will be our result defined in our custom interface. All right, and I mean, just this function drive circle, which is used in the loop here, that is just publishing a velocity with the speed that we set, which was 0.5, I think, over here. Yeah, so this will be 0.5 because we're setting a radius, so we're going to input the radius, and this is this. So it's just going to be publishing. You can set whatever command you want here. And in here, we just, in our main function, we're just going to instantiate that class. We're going to use this in order for to process goals concurrently, the multi-threaded executor. That's outside of the scope of this video. And then we're just going to spin our node. When it's done, we can destroy it and shut down. All right, so that's basically how you make an action server. Remember, so you need to, if you're going to do it in a class, you can create your publisher, subscribers, anything you need, and then create your action server like so. You should put an execute callback, goal and cancel callback should be there. They're not necessary, but they should be there. And then do whatever process you want in your execute callback, and make sure by the end you will return the result that can be used for something else. So that's basically the main structure of an action server. Okay. All right. So hopefully that was clear. Remember, again, all you need to think about is that you created it here, and that you're doing things in your execute callback. And if it does all of this correctly, then you can return a success and be like, hey, I'm good. Whatever feedback you can use, it should be shown in with the feedback. So right here, we're actually using the feedback on how long the action should run. We don't have to, for example, in a service, you wouldn't be able to do that. So that's one of the advantages. Okay, so we have our action server here. And we can just make this smaller, and so we can see our turtlebot here, and another terminal. Again, you should be able to see the message with ROS2 interface show, I think it's called. And then if you can see this here, then you can use it. So with that, I can just do a ROS2 action, send goal, then remember what it was called. Oh, I'm sorry. This I forgot to explain. So you know how our action server is running right here? We can actually check. We'll see that in here. We have a patrol server here and just a bunch of other nodes. This is the node that's running. So if we do a ROS2 action list, we'll see that there's an action called patrol. So let's see what happens when we call that patrol. Send goal and -F, or yeah, I think it's -F if you want to see the feedback, the name of the action, patrol, and the type, remember, is custom interfaces, or whatever you name your package. I always call it custom interfaces because it's just default and you always remember that. And folder action, so just convention. And if you keep pressing tab, it'll show you what other inputs you need to include that you define in your message. So remember how over here for a goal we have to send it something when we send a goal. In this case is the radius. So that's how you see, and it's a float 32, so that's why you see this right here, the radius. So we're going to use that. So let's say we wanted to move at in a certain circle, let's say 0.5, and launch it. So you can see the feedback over here, and it's doing the time left, how much time based on this circle. So in the beginning it knows how much time it should do, and it does that while loop that I showed you guys, and it just keeps using the feedback. When the time is 0, it will be a success, like I showed you guys in the actual server right here. So reaches 0, return a success, and stop the robot. And that's pretty much it. So that's how you can use the basic way you can use a service server. Let's say, and you can just adapt this to whatever you want. Let's say we wanted to go with 0.1, so it'll be a lot quicker. Obviously, if I send it right now, I don't have functionality to avoid obstacles, but we could add that and we could send it a really big circle. But if we send a really big circle, probably it'll just crash against something. So in this case, you can add whatever you want to this action server because it's not blocked. So right here it crashed, so it's gonna go everywhere. So, but that's basically the idea. All right, so I'm just gonna kill the simulation over here. So yeah, that is pretty much the basics of an action server. So remember, you just need to instantiate that action server and use an execute callback to do whatever you want to do inside the action server. And then in a separate place, in a separate package, you can create your own custom actions to do whatever you want with it. I'm thinking you can add an action server that takes pictures while it's moving or something if a condition is true. So this is what action servers allow you to do. It'll allow you to do other things while this action server is running. So yeah, again, check if you want to learn more about action servers. Check the link in the description. We have a bunch of courses that deal with ROS2 action servers in both Python and C++. So make sure you check it out. Also in the description below will be the ROS-checked link. So if you want to try this out on your own, make sure you click on that link, and that ROS-check will pop up in your account, and you can just follow the same procedure I have right here. So let me know what you guys think in the comments, and we'll see you next time for our next video for ROS Q&A. So goodbye, you guys.